All right, welcome back, Patriots. This is Mr. Love, aka the Math Patriot, bringing you another fun and exciting lesson in the world of high school geometry. Thought we'd start off a little bit different today. Got my green screen back up and going, I'm sure you can tell. But, since we can't be at school, I thought we'd go ahead and start off out in front of the school, virtually, if not actually there. But anyway, thought a friendly site or a familiar site would be welcome to you guys. Let's get this up and going. Still got the calculator up in case we need it. And, oh, I hit the wrong one. That's where we're ending. Why is it starting from there? Let's try the first. There we go. Okay. So we've talked about arcs and their relationship to central angles. We've talked about arc length. We've talked about radian measure. Now we're going to talk about our arcs, chords, inscribed angles, and the relationship between all of those. So let me jump this guy out of the way until we need him. Okay, so if the same circle or congruent circles, two minor arcs are congruent if and only if their corresponding arcs are congruent. So here's what we're talking about here. Here arc FG is congruent to arc HJ. By the way that we show that is with a single tick mark on each one, just like we would with congruent segments. So if arc FG is congruent to arc JH, then segment FG is congruent to segment JH. Congruent arcs have corresponding congruent chords and vice versa. Those two chords are congruent. So in circle K, arc AB is congruent to arc CD. We want to find the distance from A to B. Well, since I know that arc CD and arc AB are congruent, that means that their corresponding chords are congruent. So that means that segment CD is congruent to segment AB. Therefore, 2x plus 3 is equal to 8x. Now we're just going to solve through. Subtract 2x on both sides gives me 6x is equal to 3. Dividing through gives me x equals 1/2. Now if I want to find the length of AB, I've got to plug that back in. Gives me 8 times 1/2. 8 times 1/2 gives me AB equals 4. And remember, if I'm going too fast, that's what your pause button is for. All right, example 2, we want to find the value of x. I can see here that I've got congruent chords SR and ST. So that means that the arcs SR and arc ST must also be congruent. Therefore, I can throw in an x degrees on this one as well. How does that help me? Well, I know that the full distance around the entire circle, not distance, but the measure, all the way around is 360 degrees. So let's add all those up. X plus X, sorry for that stray mark, plus 64 is equal to 360. I don't like that, 6. Okay, so let's go ahead and do our algebra. 2x equals, subtract 64 on both sides, gives me 296. Divide both sides by 2, and that's going to give me, and forgive me y'all, it's like 11:15 p.m. and I've had a long day. My mental math skills are not great right now. 296 divided by 2, I know I should be able to do that in my head. 148 degrees. All right. Example 3. Circle M is congruent to circle P. Find the value of x. So it tells you that those two are equal to each other. Basically, I'd know that we have the exact same radius on both whenever two circles are congruent. So since we know that we have congruent circles, and then I've got my arcs marked as congruent here, that means that their intercepted chords are also congruent. So that tells me 6x is equal to 2x plus 24. subtract 2x, 4x equals 24, divide through x equals 6. All right, example 4. Again, we have congruent chords here. I'm sorry, congruent circles, which again means my two radii are congruent to each other. And it tells me that this one is 162 and that the arc is, the chord is 9x minus 78. Over here I've got 198. Well, I wonder, what is 360 minus, I'll calculate over here, 360 minus 162. Hey, that is 198. So here we've got 198 degrees. Well, if this over here is 198, then this must also be 162 degrees, which means I've got two congruent arcs. Therefore, I have congruent chords. So I can set those two chord lengths equal to each other. 9x minus 78 is equal to 3x. All right, do our solving skills. Negative 78 equals subtract 9x. It gives me negative 6x. Then let's divide through, and once again, my mental math is failing me. 78 divided by 6, and I can get away with no negatives there because the two negatives will cancel out. Gives me x is equal to 13. All right, now this one is probably the strangest part of this lesson. I say strange, it's just the one that's not going to be the most thought process involved here. So I want you to notice this diagram down here. Now the fact that these are two opposite chords is, two opposite radii is kind of irrelevant. This could have worked had this radius OZ gone off this direction. So don't get stuck on the idea that WZ is a diameter. Okay, what is important here is that WO is a radius and OZ is a radius. Okay, so in a circle, if a diameter or radius is perpendicular to a chord, so here we've got WX that is perpendicular to AB, okay, then it bisects the chord and its arc. So here I've got a radius that's perpendicular to a chord. That means that AX is congruent to XB, and arc AW is congruent to arc WB. The exact same thing would apply down here. Since OZ is a radius and it's perpendicular, then RY is congruent to YS, and arc RZ is congruent to arc ZS. Okay, so that was all this first one. Now number 2. In a circle, the perpendicular bisector of a chord is a diameter or radius. That's basically the converse of what we just talked about. If we have a chord AB, then the perpendicular bisector, so it's perpendicular and it cuts it in half, so AX equals AB. If I have a perpendicular bisector, then by default, WO must be a radius. Okay, in a circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. What that means is that AB is congruent to RS only if XO is congruent to OY. That means that the distance from the center to the line must be congruent in order for these chords to be congruent. Notice when we measure distance, we're always doing right angles. We're doing a perpendicular line. So here is the summary of this whole thing. Okay, if WZ is congruent to AB, so if WZ is congruent to AB, then AX is congruent to XB, and AW is congruent to WB. Same idea applies on bottom. Also, the other way around. I'm going to do this one with green to show you the, well, go ahead and mark this one as, and mark this one as red. And now let's do this one in green. Okay, if OX is congruent to OY, so if OX is congruent to OY, then AB, do that in 2, then AB is congruent to RS. So then AB is congruent to RS. Those two are congruent together, are congruent to each other. Also, do this one in purple now. If AB is congruent to RS, so now then we've got this one that we're doing this way, then AB and RS are equidistant from point O. So then again, those two. Notice the green, I went from the diameters, or from the radiuses, the radii, to the length of the chords. Then in purple, I went from the length of the chords down to the radii. Basically, those are all three of those concepts go together, and we'll be using those in and out as we go over the next few examples. Okay, so circle G, measure of arc DEF equals 150 degrees. So this whole arc is 150 degrees. And find the measure of arc DE. Well, here I've got EG. EG is a radius and it is perpendicular. Therefore, arc DEF has been cut in half by segment DGE. So the measure of arc DE is exactly 1/2 the measure of arc DEF. So that means it's just equal to 1/2 times 150, which is 75 degrees. All right, I'll be honest, this one took me a second of looking at it. Whenever I first saw it, it was a little bit overwhelming at first, but it's not that bad once you understand what is going on. Okay, first off, it tells me that the diameter QS is equal to 14 inches. Now, if QS is equal to 14, then VS is going to be equal half of that, which is 7 inches. The important thing here is that the radius is 7 inches. Now, we also know that RT is 10 inches long. Now, that is this entire length. So we know that we have VS as a radius, and it is perpendicular here at angle VUR. Therefore, it has been cut and RT is bisected. So each piece RU is half of that, which is 5, and UT is half of that, which is also 5. Now, at first I was like, how in the world am I going to use that to find VU? Until I realized that this is the important part. The radius is 7. All radii are 7. So I could draw a helper radius here from V to R. That one is also going to have a distance of 7. I now have a right triangle that I can solve for the third side. So I know that VU, I'm just going to go ahead and jump into my Pythagorean theorem shortcut, is equal to the square root of 7 squared minus 5 squared. So that gives me the square root of 49 minus 25. 49 minus 25 is 24. And then I'm going to go ahead and break down this into 4 and 6, and then 2 and 2. There's my pair. So I've got 2 root 6 inches. I know that was a lot, combined stuff from a couple different units there. Important part is use that helper radius VR and you will be all right. Feel free to go back and review some of that stuff as needed from previous units for reducing radicals. All right, example 7, it tells me that EF is congruent to GH. So this chord is congruent to that chord, and I know that congruent chords are equidistant from the center, which means that 4x minus 3 must equal 2x plus 3. So 4x minus 3 equals 2x plus 3. Subtract 2x on both sides, gives me 2x on the left. Add 3 gives me 6 on the right. Therefore, x equals 3. And the famous question, are we done? And if you're there, or if you were in class, I'd hope you would be saying, no, not done. All right, we got to jump back in. PQ is 4x minus 3. So PQ equals 4 times 3 minus 3. 4 times 3 is 12, minus 3 is 9. And now we're done. All right. In circle R, it tells me that MN is congruent to PO. Exact same setup. You know what? I'm going to go ahead and skip this one just for the interest of time. Exact same setup as before. Set them equal to each other, solve, plug it back in. You are good to go. All right, inscribed angles. Okay, an inscribed angle, I'll let you read that if you want to, but here is the basic idea. Here we have an intercepted arc, which is QS, the one that's being intercepted by the two endpoints of the angle. Earlier in the unit, I guess it was last lesson, we talked about central angles, where the vertex was over here at the center. Now we're going to talk about another angle that is over here on the circle edge. That is an intercepted arc with an inscribed angle. Now, what you need to know about the inscribed angle is it doesn't matter where on the circle it is. I could put it over there. This is still over here at point, I already have an S. Over here at point T. That's still an inscribed angle. I could also put another point down here, Z. That's an inscribed angle. It doesn't matter where on the circle I place the inscribed angle, or the vertex of the inscribed angle, the properties I'm about to show you in the next slide are going to hold true. So, when an angle is inscribed in a circle, so here we got angle E is inscribed inside the circle, then the measure of the inscribed angle equals exactly 1/2 of the intercepted arc. So here angle E is going to be exactly 1/2 of arc DF. Now that's simple enough because all that tells me is that if angle DF, let's just throw out a number here, is, don't want to use a highlighter, I'm going to use a pen, is 100 degrees, then angle E must be half of that, which is exactly 50 degrees. Okay? Works the other way around. If angle E is 50, then angle DF is 100. Now, like I said earlier, it doesn't matter where on the circle I place the inscribed, or the vertex. Let's draw, call this point H over here. You'll notice whenever you look at this that DF is my intercepted arc. Now, angle E is inscribed inside of that angle, or is the inscribed angle. We also know that H is now also an inscribed angle, and they both intercept the exact same arc. Therefore, this must also be 50 degrees. Anytime that two inscribed angles intercept the same intercepted arc, then those two angles are going to be congruent to each other. So angle E is congruent to angle H, and you'll notice this little kind of hourglass figure, kind of like the Black Widow logo that we've got going on there. Let me go ahead and change this one over to green. This hourglass. Anytime you see those, you know that those two angles, E and H, are going to be congruent. We also know that D and F are congruent to each other as well because they intercept this angle over here. That'll make more sense as we go through them. And my ink color, let's do it in purple now. Okay, find the measure of angle X. Looks like angle X is my inscribed angle on the right. It is an inscribed angle and it intercepts arc ZW, which is 86 degrees. Therefore, the measure of angle X is equal to 1/2 the measure of arc ZW, which is 1/2 times 86, which, hey, I can't do that one in my head. That is 43 degrees, just cutting it in half. Okay, find the measure of arc XY. Well, here we got inscribed angle Z, intercepted arc ZX or XY. So 1/2 of arc XY is equal to the measure of angle Z, Z. So whenever I plug that in, 1/2 times XY is equal to 52 degrees. We're going to multiply by 2, and X, the measure, should have a measure there. Measure of our XY, double that gives me 104 degrees. Simple enough. All right, let's jump over and do one of those hourglass figures. Now, over here, we've got angle R and angle S. Now, if I follow S over, it's going to intercept arc TQ. And also notice the angle R also intercepts TQ. What that means is those two angles must be congruent to each other. So 12x minus 13 equals 9x plus 2. Solving on both sides, we're going to get subtract 9x, gives me 3x. Add 13, gives me 15. Therefore, x equals 5. Don't take the bait, we're not done yet. If x equals 5, measure of angle R. Measure of angle R is equal to 12 times 5 minus 13, which is 60 minus 13, which is 47 degrees. All right. Example 12, another one of these hourglass figures. So we know that, let's see, we want to know the measure of angle A and the measure of angle C. Let's start with angle A. Angle A, its intercepted arc is BC. Now we also know that D also intercepts arc BC. So that must mean that the measure of angle A equals the measure of angle D. So 6y minus 2 is equal to 5y minus plus 8. Let's solve. Subtract 5y on both sides gives me y. Add 2 to both sides gives me 10. Now let's plug that back in. Measure of angle A is equal to 6 times 10 minus 2. 16 minus 2 is 58 degrees. We also want the measure of angle, this one in red this time, measure of angle C. Angle C intercepts arc AD, and so does angle B. Again, those are equal. 6x minus 3 equals 7x minus 11. Subtract 6x on both sides gives me x on the right. Add 11 on both sides gives me 8 on the left. Then I want to do the measure of angle C is equal to 7 times 8 minus 11, which is 56 minus 11, 56, which is going to be 45 degrees. All right, I'm getting close to the end here. Inscribed angles. Inscribed polygons. Now, there's actually a lot going on inside this picture. Two separate concepts that I've consolidated in one image. These two concepts do not necessarily have to go together, but I want to go ahead and show them to you at the same time, just to keep things nice and concise. Okay, an inscribed polygon is one whose sides are chords of a circle and whose vertices are points on the circle. So basically, this inscribed polygon, A, B, C, D, all 4 points are on the circle. Now, there's several things you need to know, especially about inscribed triangles and inscribed polygon or inside quadrilaterals. Okay, so if an inscribed angle of a triangle intercepts a diameter, so here let's focus on triangle BCD. Okay, notice that angle C, its intercepted arc is arc BAD, which is a semicircle. Okay, important here, the thing is that BD is a diameter. Well, this over here is going to equal 180 degrees. So arc BAD is 180 degrees, which means that the intercepted arc, the inscribed angle is exactly half of that. Therefore, angle C must be a right angle. The exact same concept applies for angle A over there. So that since this side over here, arc BCD, is also 180 degrees, then we know that angle A is also 90 degrees. You're going to see this picture drawn quite a bit, where we have a diameter drawn, a little pokeball going on there, and then if I draw an inscribed angle off of that, this has got to be a right angle. Let's pretend I actually hit the center there, or hit the edge of the circle there. Okay. Now, the other thing that you need to keep in mind is notice what ended up happening with these two arcs, or opposing arcs that I gave you. Over here on the left, this side was 180 and this side was 180. Notice that's going to happen no matter whether it's a diameter or not. Okay, let me do this in dark blue. Let's use my other two. So let's use arc AC and then arc ADC. See, it still encompasses one or the entire circle. What that means is that since opposing arcs equal 100 or equal 360 degrees, that means that the opposite angles in an inscribed quadrilateral are going to equal 180 degrees because the inscribed angles are half of the entire circle. So the measure of angle C plus the measure of angle A have to equal 180. Also, the measure of angle D plus the measure of angle B have to also equal 180 degrees. So, two important things off of this slide. First one is this up here, that if a inscribed angle intercepts a diameter or a semicircle, then it is automatically a right angle. And also this down here, opposite angles in inscribed quadrilateral are supplementary, add up to 180 degrees. All right, let's take this down to the application level because it makes a little bit more sense that way. Here, WX is a diameter and Y is an inscribed angle. That means Y must be a 90-degree angle. Now what that tells me is my other two angles inside a right triangle must also add to 180. Add to 90. So x plus 12 equals 90 degrees. So 2x equals, subtract 12 gives me 78 degrees. Then divided by 2 gives me x equals 39. Well, therefore the measure of angle W equals 39 plus 12. 39 plus 12 is going to be 51 degrees. Okay, example 14. Now, we're going to use that property we talked about earlier, opposing angles. Okay, let's focus here on angles R and P. Angle R intercepts arc QPS. Angle P, if I go across, intercepts angle QRS. Together they intercept the whole circle, which means since they're inscribed angles, there have to be half of that. They're supplementary. So we know that 75 plus 3x is equal to 180. Subtract those off. 180 minus 75 gives me 105. Divide that by 3. X equals, grab my calculator just in case. I think it's 35. 105 divided by 3 is, yes, 35. Now, to find the measure of angle R and the measure of angle S. Measure of angle R is equal to 3 times 35. So, measure of angle R is 105 degrees. Measure of angle S is equal to 2 times 35. So the measure of angle S is equal to 70 degrees. I just realized I did that the hard way. Let me show you the easy way here. Shift over to a different color. Get rid of some of this stuff over here. Okay, since these two are supplementary, those two are supplementary, all I know is that the measure of angle R is equal to 180 minus 75. It should be a minus, which is just 105 degrees. Same logic applies for the other one. So, sorry about that. I did it the long way. Okay. We want to find the measures of angle W and angle X. Very similar logic to the one before it. We know that angle X and angle Z are supplementary. So 3y minus 7 plus 3y plus 1 equals 180. So that gives me 6y minus 6 equals 180. Now we're going to add 6 on both sides. It gives me 6y equals 186. Divide through 186 divided by 6 is 31. Now, let's go ahead and plug that in to find the measure of angle x. So measure of angle x is equal to 3 times 31 minus 7. 3 times 31 is 93. I don't know why that spot doesn't like it every single time. 93 minus 7, and 93 minus 7 is 66 degrees. Now, we know that, again, w and y are going to be supplementary. So x plus 18 plus 2x equals 180. Combine like terms gives me 3x. Subtract the 18 on both sides gives me 162. Divide through, and oh man, my mental math is failing me again. 162 divided by 3 is 54. Now for the measure of angle W, that equals 54 plus 18. And yes, I'm going to type in 54 plus 18 in the calculator because it is now midnight. Oh, see, I can't even type right. Plus 18 is 72 degrees. Measure of angle 2, I did that again, man. Measure of angle W. There we go. Give me 1 second here. All right, I know that was long. I know that was a lot. I'm sorry that this was not the best lesson I've ever done. And if you have a chance, go ahead and check out that video that I posted this morning. Actually, it was late last night on the class stream. Just a fun little thing that me and the rest of the math teachers put together. But until I can see you guys again, stay safe, stay healthy, and as always, stay patriotic.